Hi, in this video I'd like to show some enhancements to Illuminated Cloud's real-time static code analysis capabilities. Since the release of Illuminated Cloud 2, it's already supported some really nice capabilities in this area, with the goal being that it minimizes the number of cycles required sending a piece of source code, in particular Apex source code, to the server in order to get it to a point where it'll compile, because of course the server is the final arbiter of what is considered valid Apex or not. With Illuminated Cloud 2, there were quite a few what are called code inspections, which are these static code analysis capabilities to do things like tell you if there is a type agreement mismatch. For example, if you're trying to pass the wrong type to a method, if you're trying to assign the wrong type to the left-hand side of an assignment expression, things like if it's unable to resolve a symbol, a class name, a variable, or something like that. And it also includes quick fixes for quite a few of these. In fact, one was just introduced a few releases ago that allows you to take unresolvable symbols and have Illuminated Cloud automatically implement those for you, stub them out for you. The end goal is to get to a point where 99+% of the time Illuminated Cloud will catch things that the server would otherwise be required to catch. And Apex is a rather sophisticated language in terms of not only being a Java-like object-oriented programming language, but having an embedded query language, an embedded search language, the ability to use, of course, inheritance, use annotations to provide declarative capabilities to your code, and sometimes getting things to agree can be kind of difficult. There are two major static code analysis capabilities that have been added in this release. The first one, and I'll demonstrate both. The first one that will be demonstrated in this file has to do with agreement between modifiers and each other, and modifiers and annotations in one another. And before I jump into the demo, I'll give a couple of examples of when this is important. If you are setting up an inheritance hierarchy, the base class and its methods that are intended to be subclassed and or overridden must have certain modifier keywords. The base class must be declared as either abstract or virtual, and the overriding methods and such must use the override keyword. But then they should not do that if they're implementing interface methods, only if they're overriding class methods. So keeping things like that in mind can be a little bit difficult sometimes, and very often, at least if it's me, you have to send it over to the server before you actually remember, oh yeah, I've got to add a virtual keyword here and an override keyword here. Another example with annotations would be kind of the canonical Apex unit test, where you have to annotate the test method with an at.is_test annotation. Or with the test method modifier, although that certainly is being phased out in favor of the is_test annotation. And then similarly, once you do that, you have to mark that method as static, as a class method, and you have to add the same is_test annotation to the enclosing class to make it a test class. So these are the types of things, again, that it may take a cycle with the server to before everything will compile. The goal here is to make it so Illuminated Cloud finds all these things and pretty much takes care of them for you. So let's go ahead and dive into the demo. So as you can see, there's quite a bit of red in this particular class, because it's purposefully instrumented with a lot of these types of issues that have to do with either modifier agreement or annotation agreement, or a combination of the two. I'm going to go ahead and walk through them. I'll try to do it quickly, but I do want to show some of the capabilities that are available, and importantly, I want to show some of the quick fixes that are available for each one of these. So I'm just going to move through them in turn. The goal is going to be to have something that we can save to the server in the end, without writing any code, just having Illuminated Cloud take care of quick fixing things based on the way that we want. So the first thing we run into here is we have a method that is intending to be abstract, maybe, but is not quite abstract. So it has an abstract keyword, but it also has a method body, and it's within a class that is not itself marked as abstract. So each of these messages will be presented to the user in turn. It doesn't overwhelm you with all the errors at once, but it does present all of the quick fixes at once. So we have three available to us in this case. We can, if we want to make this an abstract method in an abstract class, we can go ahead and have it add the abstract modifier to the enclosing class, which it just did, and we can have it remove the method body, which it just did. And you can see that all the red's gone there. Now, I'm going to back that out and show what the other option is, and that is to remove the abstract modifier and treat this as a concrete method, which it has a body, things like that. And so again, it's not red. Let's keep moving through this. Okay, so now we have another method that doesn't have a body, but is not declared as abstract. This is pretty much the opposite of the previous one. So we can either have it add the abstract modifier, or we can have it add a method body, and you can see it stubs out a valid method body. If this were a method with a non-void return type, it would have added a valid return statement. Moving down, it's saying that a global method must be declared in a global class. And of course, this is not a global class. So we can either make the class global, or we can reduce the visibility of this method. We'll go ahead and do the second option. And it will present us the valid visibilities for this particular identifier. So we'll go ahead and make this public. A protected method can only be introduced for the first time in a class that is marked as virtual or abstract, that is intended to be subclassed in that method to be overridden in some way. That is the meaning of protected, is it's only visible to subclasses, to an inheritance hierarchy. You can have protected as your visibility modifier on an override of a base method that is also protected, but you cannot introduce a new method to that visibility. So we can either add the abstract or virtual modifier to the enclosing class, or we can change the visibility of this to something other than protected. So I'll go ahead and make it public. Abstract methods, abstract classes are inherently virtual already. So this is actually an extraneous and erroneous keyword. So we'll go ahead and have Illuminated Cloud remove those. And then here we have a method that actually has an implementation. It has been overridden. You can see in the gutter the down arrow, but it is not properly designated as virtual or abstract. So I'm going to go ahead, because this has a body, I'm going to go ahead and add the virtual keyword, and now that takes care of it, at least at this level. If we move to the next error, this is the other side of it. We have an override of that in a subclass, but it does not have the override keyword. So we can have Illuminated Cloud automatically add the override keyword. We also have an override keyword on this next method, but it doesn't override anything. That's an error. We can have Illuminated Cloud remove that. Apex does not support static inner types, and it does not support static members of inner types. So what we have to do here is remove the static modifier from these to be syntactically correct. Moving on to some annotations. Aura enabled can only be added to static methods or to instance methods that have this idiom of being prefixed with get to indicate that they're effectively getter methods. So we can either add the static modifier, that'll fix it, or we can rename to get Aura instance, enabled instance method. It will actually go ahead and determine a valid name for it. And Aura enabled methods must be public or global. This is private. So we'll go ahead and change this to public because our enclosing class is not global. Future methods must be static. Invocable methods must be static and must be of a higher visibility. Again, we'll go ahead and go with public. Invocable variables are actually the opposite. Invocable variables must be instance. So we'll go ahead and change this to be public and remove the static modifier that is invalid. This is the example I gave earlier, is test. Basically, we need to make the enclosing class is test. So we'll go ahead and do that, and it'll add the annotation. I'm going to use F2 to move to the next error, which brings us back to the same line. And test methods must be static. So now we have a valid test method. The next one we'll go ahead and look at. The test method modifier is more of an antiquated way to designate something as test. The isTest annotation is preferred because it actually can take parameters like see all data and things like that. While this is not designated as an error because it's not an error, it does highlight as a warning, and it does include some capabilities for adjusting it. So for example, I can remove the test method modifier from this and add the isTest annotation, basically transform that into the preferred isTest capability. Test setup must be static. Namespace accessible. The visibility of namespace accessible must be protected or public. We'll go ahead and change this one to public because we saw what happened if we introduced protected. We would have to also mark it as virtual. And a web service method must be global. So we must therefore make the enclosing type global. You can see there are three options here. But because we want this to be a web service method, we'll go ahead and make the enclosing type global. You can see that at the top of the IDE. And then additionally, web service is a pseudo visibility modifier, and therefore the global visibility specifier is extraneous and actually erroneous. So we can have Illuminated Cloud take that out. And finally, a web service method must be static. So now we have a valid web service method. A remote action must be static and must be public or global. We'll make that public. And a read-only annotation can only be added to three things. You can see examples of this just above as well. Only to a web service, only to a remote action, or to an implementation of the schedulable interfaces execute method. Well, we can't morph this method to be schedulable.execute. That would almost certainly never be what you want. But what we can do is either remove the read-only annotation, because this shouldn't really be read-only. I perhaps misunderstood the meaning of that annotation. I can make this a remote action. And if that's the case, I need to make it static. So that would make it correct. Or I can make it a web service. And again, to do that, I would have to remove this extraneous modifier and make it static. All of the Apex REST service annotations, HTTP GET, HTTP POST, PUT, delete, things like that, must be added to methods that are inherently static, and must be inside of classes that have the REST resource annotation, and those require a URL mapping attribute. So we'll just say /path and move back down here, and we'll make this static, and those must also be global. And then there's one other thing that's highlighted also as a warning here, and that is something denoted as test visible should not be public or global. The idea of test visible is to give access to something that's not otherwise accessible. Again, this is a warning, but there are two options that are given. Okay, this should not be test visible. We can just remove that, or we can lower the visibility to either private or protected. So I'll just make that private. So one other example I want to show of this is in an inheritance hierarchy. Everything I show was in the same file. Let's say that we have bad inheritance relationships across classes that are in separate files because there are other restrictions. So here we have a private top-level class, which is only allowed in certain cases, for example, test classes, a private inner class that is intended to be overridden, it's a virtual class, and a private abstract method that's intended to be implemented. So this, you can see that all those are denoted as errors, and we can see the top-level type must have public or global visibility. A class that is overridden in another file cannot be private, and a method is overridden in another file that cannot be private. So let's move to the other file, and we can see the other side of the same issue. The extended base class is not visible from the current class. The overridden base method or abstract base method is not visible. We can fix these from here, so I can go ahead and change the visibility to, say, public. I can also change them from here and say change this to protected, and that fixes it, and you can see that there's only one error left. We'll move up here, and this must be public or global. We'll change it to public. All the errors are gone here, and all the errors are now gone here. And as I promised, we'll go back over here and try saving this, and if all goes well, it saves with no errors. And we didn't write any code. Illuminated Cloud did all of that for us. So that's one of the major sets of static code analysis that was added, and hopefully that will help with some of this relatively rote modifier and annotation agreement work that's required in order to get something that can be sent to the server and actually save. Now I'll show the second of the static code analysis capabilities that have been added in this release. The code inspection here and its associated quick fixes are around control flow analysis. And if you're not familiar with that term, it effectively means an examination of the way that logic flows through your methods, your constructors, your property accessors to determine when control is returned from that invoked entity to its caller, how it is returned. So is a return value provided? Is it not provided? Does that match the signature of the method or the property accessor? And if it doesn't, that's an error. Are statements in place that will never be executed, effectively unreachable statements. These are the types of errors that you could have that you wouldn't see until they got to the server necessarily unless you were looking for them. But now Illuminated Cloud will not only identify them, it will provide options to fix them in rational ways. So let's take a look. The goal here is going to be, just as before, to take this file. As you can see on the right, a lot of red in the gutter. Take this file and put it in a state where it can be saved to the server with no issues at all, and do that without having to write any code, just using the quick fixes provided by Illuminated Cloud. So let's just start stepping through. The first one is something I alluded to a moment ago, and that is an unreachable statement. An unreachable statement is a statement that occurs in a statement list after a statement that returns control to the caller, whether by returning a value or by throwing an exception and unwinding the current call stack. So as you can see here, we have multiple statements after a return statement in a few different ways, and multiple after an exception being thrown. Same thing. And so if I move to that and look at the fix, it's effectively to delete that statement. You could also comment out that statement if you wanted to, for example, if you were only temporarily putting a return statement in. But that is not one of the introduced fixes. You could do that using controller command /. But let's take a look at the actual code fix. So we'll delete the statement. It's gone. We still have several of these, though. We have one here, 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 all the way down to here. So let's go back to the first one. And you can also run these in bulk. So I'm going to run this fix for all the problems in the current file. And as you can see, they're all gone. And now we can move on to the next class of problems. So moving down, here's another example. We're returning a value from a method that has a void return type. That obviously is not going to work. So we can take a look at the options that are available. So we can delete the return statement and treat this as a void method. That'll take care of it. We can leave the return statement but delete the return value if I wanted to actually interrupt the flow of logic and return to the caller. Say I was in a conditional or something, not necessarily return a value, but just actually exit to the caller at that point. You could just delete the return value but retain the actual code flow in terms of the graph. Or we can change the return type of the method to match the expression being returned. So because a query can return, in this case it's returning objects, not things like aggregate results, can return either a single instance of that object type or a list. It is showing multiple return types and providing us with the opportunity to select the one that we want. So we'll just say it returns a list. And as you can see, that's now fine. Here's another example. We have something that returns a string, but all we have is a return statement, no actual value. So a couple of options here. We can make this a void method, or we can add a return value and it will automatically add in a null value and allow me to put Scott as a value and hit enter, and now that's valid. Here's another example. There's no return statement whatsoever. Basically, it has reached the end of the execution logic of this method that is, by its contract, supposed to return a value that can be assigned to a string, and it never found anything that did that. I'll show some more complex examples of this below, but for the moment, let's just take a look at what options are available. So one option is to make this void, of course, and that fixes it. Another option is to add a full return statement, and we'll just call this fixed. And we may obviously want to get our value from somewhere else, but at the very least, we have made this syntactically valid. Moving to the next one, a constructor technically does return a value. It returns an instance of the class for which it is a constructor, but you don't have to explicitly return anything. And in fact, to be precise, you cannot explicitly return anything. So in this case, I cannot change the return type of this. What I can do is either delete the return value, same thing I said earlier. Maybe I want to interrupt the flow of logic and return immediately, and that I do want to retain, but I don't need to return a value. Or I can just delete that statement altogether. Moving down, here's a property read accessor that has no return statement. So I have to add a return statement. You can see instead of adding a value of null here, it adds the thing that you would normally add, which is returning the property value itself. And here we have a property write accessor, which is implicitly a void method. And so you either have to delete the return statement or delete the value. So it's just a return. So we'll just go ahead and get rid of that. And now we have another property that has a return statement but is missing a value. So we'll just add a value, and again, it's going to return the value of the enclosing property. Now, I promised earlier we get into some more interesting examples of basically missing return statements. You can see there are multiple return statements in this, but there are branches of logic in this method that are not covered by a return statement. So for example, if 1 is equal to 2, we would return here. If 3 is equal to 4, we'll throw an exception here. Obviously, neither of those are going to be true, so we're going to end up in this else block. That doesn't return. That will move out to this scope. That doesn't return. Illuminated Cloud has detected that and gives us the option to either change this method to void or add a return statement. So I'll add a return statement, and that fixes that. Let's look at another example. Here is a conditional statement, an if-else statement that ends this particular method. Illuminated Cloud knows that if you have a conditional statement with an else block and that ends, the logic that it is by itself can be comprehensive as long as there are return statements in each. So the if block returns something, the else if does not, and the else block does. So we can either add a return statement at the end, or if what we were trying to do is this, that fixes it as well, because now all of the code paths in the if statement that ends this particular method interrupt the flow of logic. Similar with a switch statement. Again, we can see here that the branches in the switch statement, this one does include a catch-all, a when else. This throws an exception. This returns a value. There's no return here. This one does not return a value. Therefore, we have a branch of logic that does not return a value. By uncommenting that, the problem goes away. It's no longer highlighted down here. And the last one is a try-catch. Finally, we have a try block that returns something. If that everything went without a hitch, this would be your return statement. If it didn't and you caught an illegal state exception, it would return this message. If it caught an illegal argument exception at present, it would do nothing. The finally block is allowed to execute no matter what as the return value is being returned. So no return is required. There's no return statement here. So therefore, we basically have a dead end path. So we'll go ahead and fix the illegal argument exception, and the world is a happy place. And now, as promised, I'm going to save it. And if all goes well, this will actually deploy to the server without any errors. So let's take a look. Yeah, so it deployed and succeeded. So that's an example of a full set of fixes that are for problems that you might have had that would have been difficult to detect, that Illuminated Cloud will now detect for you and hopefully save you cycles to the server in order to find and fix those. I hope you found this useful, and certainly if you find any issues with it, log an issue, provide a standalone example that reproduces it. That's going to be the easiest way for me to fix it, and I'll take care of it. And thank you very much for your time.